Welcome to the deep dive. Today we're plunging headfirst into something really central to how software works these days, microservices orchestration. If you've ever wondered how those massive apps you use, streaming services, big online stores, how they stay up, how they scale so smoothly, even with millions using them. Well, this deep dive is for you. Our mission really is to cut through the jargon and give you that shortcut to, well, really understanding this. We want to find those aha moments for you. Okay, let's unpack this. We've been looking at a beginner's guide, pulling out the key bits, the really important stuff. So let's start right at the beginning. Microservices. What actually are they? Think about an online shop. Instead of one huge chunk of code, it's like broken down. Little independent pieces. Maybe one for login, one for payments, one showing products, each doing just one job.
Exactly. Each piece is a microservice. Small, focused, does one thing well.
Okay. But then the challenge is, how do all these separate bits, maybe built by different people, how do they actually work together smoothly without chaos?
Right. And that's where orchestration comes in. Think of it like a conductor for an orchestra. You've got all these musicians, the microservices. The conductor, the orchestration system makes sure they all play together, create the whole song, which is your application. So this conductor, it manages the microservices, makes sure they work, they talk to each other properly, keeps the whole app running, no matter how many services there are.
That conductor analogy works well. So what does this manager, this conductor, do specifically? Like day-to-day tasks?
Oh, quite a lot. It handles starting and stopping services,
Yeah.
scaling them too. So if one part, say the search function, suddenly gets slammed with users, the orchestrator automatically makes more copies of it, handles the load, and then when things quiet down, it removes the extra copies, saves resources, right? Yeah. It also connects them so they can communicate. And, crucially, handles problems. If a microservice crashes, maybe a bug, the orchestrator often spots it and just restarts it automatically. And these services, they're usually packed up in containers, like Docker containers. Makes them easy to manage and move around. The orchestrator deals with those containers.
Okay, I get the what. But why? Why do we need this extra layer? Couldn't you just manage them somehow? It sounds complex.
Yeah.
I mean, managing dozens, maybe hundreds of these manually, that sounds like a nightmare, right? Is that the real reason? The sheer scale?
That's absolutely a huge part of it. The complexity just explodes. You've got all these services in their containers, maybe on different servers, maybe in the cloud, trying to keep track of all that manually. What's running, where it is it healthy? It's practically impossible. Error-prone for sure. Orchestration automates all that tracking and management. It prevents the chaos.
Okay, so it handles the baseline complexity. But what about when things change fast? Like sudden spikes in users? You mentioned scaling.
Exactly. Automatic scaling is a lifesaver there. Think about like an online store during a huge sale. The part handling shopping carts might get overwhelmed. The orchestrator sees this, spins up more copies instantly.
Ah, okay.
And then scales them back down later, saves money, saves resources. Although it's worth saying, orchestration manages the scaling, but if the service itself is badly designed and slow, well, scaling it won't magically fix the core problem. Design still matters.
Good point. What about things just breaking? Stuff fails, right?
Absolutely. And that's where reliability and recovery come in. If a microservice crashes, the orchestrator detects it, restarts it, maybe moves it to a healthy server. It also usually spreads services across different machines, so if one server dies, your whole app doesn't go down with it. Avoids that single point of failure. I remember trying to update systems before orchestration. It was terrifying. Orchestration makes things way more resilient.
And the communication. How do these separate bits, potentially scattered everywhere, talk to each other efficiently?
Yeah, another key job, efficient communication. They need to talk constantly, like a payment service has to tell the order service payment complete, right? Orchestration sets up those connections, manages them, makes sure they're fast and secure, so data flows properly.
Okay. And updates. Rolling out new features.
Simplified updates is another big one. You can roll out changes gradually, update just a few instances of a microservice, test it, see if it's okay, then roll it out further. All while the main application stays online, users often don't even notice, which is huge for services that need to be available 24/7.
Right. So pulling it all together, it manages the complexity, scales automatically, handles failures, sorts out communication, simplifies updates, makes everything more reliable, basically.
Pretty much. It handles the hard stuff, but it's not like the complexity vanishes entirely. It just gets managed by this sophisticated system, which, brings its own set of things to learn and manage. It's a trade-off, but usually a worthwhile one for the power you get.
Makes sense. So
Yeah.
know what it is, why it's so crucial. Let's talk tools. What are these actual conductors? What platforms are people using?
Okay. Well, the big one, the most popular, is definitely Kubernetes. K8s, you'll often see it written. It's open source, designed to manage containers across loads of servers. Handles starting, stopping, scaling, networking, all of it. It's kind of the standard for bigger companies with lots of microservices. Hugely powerful, automates tons, works pretty much anywhere cloud, your own servers. And it has a massive community, so tons of help, tutorials, add-ons available.
Okay, Kubernetes sounds powerful, but maybe complicate, like you said, maybe overkill if you're just starting or have a smaller setup.
Yeah, exactly. It has a notoriously steep learning curve. It's a serious commitment. Sometimes you hear about needing a whole team just for Kubernetes. So for simpler needs, there's Docker Swarm. It's built right into Docker, much
Yeah.
simpler to get started with. It still does the core orchestration things, managing containers, scaling, load balancing, but with way less complexity.
So if you're already using Docker anyway.
Exactly. It's a very natural fit. Great for beginners or smaller projects where Kubernetes might be, well, too much.
And what if you're all in on a specific cloud provider,
Yeah.
like AWS or Google Cloud?
Good question. That leads to cloud-based orchestration tools. Think AWS has ECS and EKS, Elastic Container Service, and Elastic Kubernetes Service. Google has GKE, Google Kubernetes Engine. Microsoft has Azure Kubernetes Service, AKS. These are basically managed services from the cloud providers. Often they run Kubernetes under the hood or something similar.
And the advantage there is,
The main benefit is the cloud provider handles a lot of the underlying infrastructure management for you, setting up servers, patching, maintenance. They take care of much of that, so your team can focus more on just building the application itself. Plus, they usually integrate really well with other services from that same cloud provider, databases, storage, whatever. So yeah, whether it's the powerhouse Kubernetes, the simpler Docker Swarm, or these integrated cloud options, they're all popular because they tackle that core challenge. They simplify managing all those microservices, make it feasible. Strong communities behind them too.
okay, so we've really dug into microservices orchestration. We've covered what it is, why it's so critical for, well, most modern software, and the main tools people use. It's like the ultimate traffic cop for all your application's little pieces.
Yeah, or the conductor keeping the orchestra in time. It's all about coordination. And hopefully, understanding this gives you a much clearer picture of how these complex systems we rely on actually work, how they stay reliable and scale up. It's foundational stuff, really.
Absolutely. So thinking about this landscape, you've got Kubernetes, the beast, Docker Swarm, the simpler option, the cloud providers integrating everything. What does this variety mean for your choices when building something new? How do you pick the right conductor for your specific symphony? And looking ahead, how might these tools keep evolving to make managing even more complex systems feel, well, almost easy? Something to think about.